Hello, hello. Recording in progress.
Hello, hello, testing, testing. Hello, hello. Good evening, everybody. Am I audible and am I visible? Okay, thank you, thank you. Okay, so let's spend around 5 minutes just familiarizing with ourselves, amongst ourselves. Um, I would love to know who you guys are and where are you coming from. And before that, I will introduce myself. I am architect Asim and I'm based in Nagpur. Currently, I'm in London for 2 months, but in Nagpur, I have my own architecture firm, Archi Codes. Um, I did a bachelor's of architecture from Nagpur through VNIT College, and then I went to Mumbai and did a Master of Architecture in Advanced Architectural Design, and I also did my MBA in Financial Management. That has helped me a lot in my firm. So during my master's in architecture, in advanced architectural design, I came across this scripting, Grasshopper, advanced designing softwares and methods that sparked the interest to combine these two fields, the architecture and scripting, coding, computational design, computer engineering. That's why my company's name is Archi Codes. So yeah, and currently I'm doing several projects in Nagpur and remote projects for an NGO, one government project. In London, I've got two projects. I mean, I'm yet to get it. I'm still talking to the client. So pretty interesting stuff. Um, how this globalization thing works. So yeah, and I have an immense passion towards teaching, especially teaching scripting, visual scripting stuff like Grasshopper and Dynamo. The thing is, in my current practice, I'm not able to utilize it to as much as I want to utilize it. But to maintain that spark and interest in this, I love to teach it as much as possible. So yeah, that's about me. What about you? I would like to know, what are you guys doing right now? Are you students? Are you working? Like how many years of experience, kind of thing? And about Grasshopper, have you, like, what level of Grasshopper are you familiar with? Have you never heard of it? or have you heard of it, or have you played with it, and things like that. So, Mandir Singh, shall we start with you, please? Good evening. Yeah. Mm-hmm. Wow. Amazing. Awesome. Oh yeah, yeah. Okay. Okay. Mm-hmm. Mm-hmm. Okay. Okay. Uh, Brilliant. Nice. Wow. Yeah, yeah, yeah. That's just really nice. I hope I see myself in you, like after 8 years, 7 years. I hope to be that guy. Brilliant, brilliant, very nice. Lovely. Thank you so much, Mandir. Polumi Diokare. Sorry, did I pronounce your name correctly? Diokare, yeah. Sorry. Okay. Mm-hmm. Okay. Lovely, lovely, lovely. That's really nice that you have a good background in sustainable architecture. So that would be really helpful, and it will cut down a lot of our time. So thank you so much, Palami. Uh, Sh- Sharvari, would you like to introduce yourself, please? Hi, hi. Oh, nice. uh, Sustainable architecture. Yeah. Okay. Mm-hmm. Yep. Awesome, awesome, awesome. Thank you, Sharvari. Sunidhi, would you like to go? Hi, Sunidhi. Yeah, yeah. Thank you. Mm-hmm. Yeah, Bangalore. All right. Nice. Interesting. Awesome. Okay. Okay. Yeah, 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 yeah. Awesome. Awesome, awesome. That's really nice that you have that inherent interest towards Grasshopper, because it is a bit complex and daunting to look at. Yeah, lovely, lovely. Definitely, definitely. Thank you, Sunil. Also, Polami, Mandir, and Sharvari, um, what level of Grasshopper are you familiar with? Mandir, I think you said that you have seen your wife do something, right? Okay. Yeah, yeah, yeah. Definitely, yeah. Ah, okay, okay. Awesome, awesome, perfect. So you are familiar with. Hmm. Yeah. Oh, brilliant, brilliant. Perfect, perfect. Thank you, thank you. Yeah, follow me. Okay. No worries, no worries. Perfect. Thank you. Yeah, yeah, yeah. Perfect, perfect. No worries. Okay. Brilliant, brilliant, Shalvari. So what I'm doing is I'm just creating a profile for each of you, and when we go through the sessions, I will know what to ask which person. So the people who are intermediate and already know a bit, maybe I'm gonna leave them and leave them in the sense you're gonna continue doing your work, while those who are at the very beginning stage that require some hand holding, I'm gonna give more attention to them. Of course, I'm gonna give attention to everybody, but at different levels. Um, so Shreya, would you like to go? Hi, Shreya. Hmm. Lovely. Okay. Brilliant. In Singapore, you did a master's in sustainable design, right? Uh, MSc in sustainable. Interesting. And so I don't know anything about it. In the sense, I just want to know, oh, what would be the general precipice of that course? Like, are you looking into materials and design strategies more, or are you looking into tools, simulations more, or like a bit of both? Yeah, yeah. Okay. Building performance was it? Okay. Hmm. Okay. Nice. Understood. Okay. Perfect. Yeah. So this thing is good. Yeah, yeah, yeah. Because in so Grasshopper is a tool that we'll be using to implement what you have learned, the sustainable theory. So, for example, you can define a comfort. You can like define a comfort zone on at a particular city, and then Grasshopper we can use simulations to check if it is conforming to your definition of comfort for that part. So yeah, that's how we'll be going about. And Grasshopper, you have you know that it runs simulations and stuff, right? But you haven't used it, right? Okay, but you know about how simulation works, so that's nice. Understood, understood, perfect. Thank you, Shreya. Pratiksha, would you like to give a go? Hi, Pratiksha. Mm-hmm. Master in sustainable design, perfect. Perfect, perfect. Okay, Pratiksha. Oh, nice. Okay, okay, but you have. Yeah, yeah, yeah. Nice, nice, nice. Brilliant. And just to make sure, we all have Rhino installed, right? Like, so we will be working together, right? Is there anybody who will not be working in the sense does not have Rhino installed? You can just like raise your hand and Okay, perfect. So I'm assuming we all are gonna work together. So what I'm gonna go first is like I'm go through the presentation a bit, just revise sustainable concepts and what Grasshopper is, how we can use it, its examples. Then we will fire up our Rhino, and slowly we are going to create our first scripts onto that. Expect me to ask you to share your screen, okay? And so yeah, so be ready at least mentally for that. I would love to spend time with each and every one of you, and we'll go through this together because it is a bit difficult and complicated. So let us begin. I'll just put myself here. Okay. All right, so we've got 2 hours, 1:45. So, I mean, I suggest to keep videos on. I mean, of course, if you are comfortable, because it's late night there and you must be tired throughout the day. It's a Monday. I mean, it's completely fine if you don't have your video on. Also, I have like multiple screens and it helps a lot. So if you have multiple screens, that would be really nice. Interact, ask, discuss freely. You can stop me anytime you want. No doubt is small enough, so you can ask me anything. And at many times you are going to feel like lost, or you would feel like, oh, why am I teaching this part? Why are we spending so much time on certain topic? But just trust the process, and it will all the pieces will come together later on. Play with Grasshopper. It's just play it like a game. I mean, just do random stuff, and you'll be fine with it. Also, just I think my video is reversed, right? Is my video mirrored? Oh, sorry. So, like, can you read these suggestions? Please keep it. Oh, that is readable. Okay. In my screen, it is coming all mirrored. So I just want okay. Okay. Awesome, awesome. Thank you, Sunidhi. And is it clear, like readable, or like even this is readable? Perfect, perfect. Thank you, Sunidhi. And lastly, showcase your experiments. Like if I tell you to make a rotating tower and then you create something exploded tower, just show it off. I mean, that's also a great thing to do. So yeah, it's a chill session, and we'll work on this together. So we are going to look at the introduction of Grasshopper. What is Grasshopper? The examples and stuff. Then we are going to start using Grasshopper. We are going to create lines, simple points, stuff. We will just get familiar with how to work in the Grasshopper canvas, and then we are going to look at the irradiation analysis, daylight factor, sun hour analysis, using some of its plugins like Ladybug and Honeybee. So this will come in the later sessions. And after that, we look at a bit more advanced stuff. We can create facade. We can optimize facade design that is responding to the sun path and things like that. And lastly, we are going to go like full on. I mean, we are going to go into algorithms, and we look at evolutionary, multi-criteria evolutionary generative optimization. And that's really cool and interesting. I've written paper and I've done thesis on that. So I really love to talk about it. So that would come in the last part. So next, introduction to Grasshopper. So what is Grasshopper? I just took some of these definitions from famous websites. So Simply Rhino defines it as Grasshopper is a cutting edge parametric tool which works with Rhino to allow a powerful and efficient new way of designing. Secondly, it is a versatile plugin that takes design complexities to a newfound level by exceeding the limit beyond Rhino 3D. So that is important, exceeding the limit beyond Rhino 3D. We can, so you can see these images below. So we can create these anywhere. We can even do it on AutoCAD 3D. It will take us like weeks to do that. We can do this in SketchUp. We can do this in Rhino. But then why Grasshopper? So Grasshopper does this in within like half an hour or 15 minutes. And we will see why it is much more superior than designing it in the conventional softwares, Rhino, AutoCAD, and SketchUp. Then thirdly, there is this, that it is a plugin. Grasshopper is a plugin that allows the user, you and me, who are from a non-coding background, we are architects, but still we can design using coding and algorithms. Throughout our tenure, we have never been taught to design using coding and algorithms. So that's like a completely new way of designing. For example, in art, you can create art by a pencil drawing lines, so that becomes a sketch. You can draw art using a different tool, that is a paint, and then doing that. But when you tell a person that just by dots I can create a design or let's say a facial portrait, that person will be like, ah, that's impossible. You're just creating dots, no lines, no shading, no smudging, nothing. But we know that dot rendering is a method of art. Similarly, Grasshopper would be this dot rendering for us. Fourthly, it allows the incorporation of complex simulation tools. So below you can see there is this is called a heat map. In this heat map, it's very intuitive. We can clearly understand that blue part must be cooler and red must be darker. Warmer. In this case, it's the opposite, I think. Like there are openings and the light is coming in and it is checking how much daylight is coming in. Since there is a building, it is creating a shadow, and that's why it's seeing all the red part. So I'm assuming, I don't know what this is, but this is what we'll be looking at. These heat maps, analyzing what is the aperture and fenestration sizes that we need for the building to create the optimal conditions. Not only that, but many more things. So, but this is how it looks, the simulations. Yeah. So how is it useful for an architect? Now, coding is like a building block. It's a brick. With a brick, we can make anything. We can make house. We can make even pavilions or airports or anything. So the brick is the building block and we can do anything. Similarly, coding is the building block which can be used to do many things. We can create games, we can create some transaction lines, cybersecurity stuff, we can do anything. But the basis of it is coding, right? We don't want to learn coding because it's a vast topic, right? We don't want to learn that. We just want, how can this help us in our field, in architecture specifically? So coding through Grasshopper, it allows automation. So let's say there is this building and there is this facade over it. I can assign certain values to it, what material is being used. I can create options. What is the cost of that material and what is the surface area that the material is being applied on. And automatically it will give me the cost of the building, of that facade, let's say. Now I can create 100 options, and once I've created this automated script, it will automatically give me the cost instantly. So I just give you a simple example of how we can automate things. Parameterizing forms. So I'll go a bit slow because parametricism, parametric architecture is a vast topic. But to explain it simply, a cube or a rectangle, a cuboid has got 3 parameters: length, breadth, height. 4th parameter could be rotation, orientation. I can control the shape of this box by controlling these parameters, right? Similarly, when we go into complex shapes, let's say this one, the parameters are can be anything. It can even be the sun path. So sun path is a parameter for my facade design. Okay, so that is parametric architecture. An equation is what is governing my design. So the equation and the variables in it becomes the parameter for my design, which Jahadeep did. So we can parameterize forms through Grasshopper very easily. Thirdly, templates are available. You don't have to reinvent the wheel. A lot of templates are available. I'll be sharing like what are the forums that are really active. You can put a question and you'll get an answer in like one day or something. But it is not something which is very small niche where only scientists and not some people are huddling together. It's a nice platform. Many people are working on it, sharing stuff for free. So there are a lot of templates available. Fourth, replicability. So it is not a free-flowing curve that you cannot repeat again. So if I create like a free-flowing curve on paper, in my entire life, I'll never be able to exactly make the same curve again, unless I'm using some tools or something. So that's what it is. Even though things look organic and random, the design that you create once can be replicated again with exact dimensions and everything. That's really cool. Integration with other software, it is not like Apple, isolated, like I'm going to create everything on my own stuff. It is integrated with other software. So at a basic level, we can export geometries very easily. At an advanced level, it can be directly interact with Revit, and I think the plan can be dynamically connected to Grasshopper. I haven't explored it, but there are possibilities that are being created every day. Then there are simulations. A simulation is a virtual environment we create to test a product before executing it. If it's a small product, if it's a cup and I just want to see how strong it is it holdable, I'm just going to create 100 cups because it's not going to cost much. But we can't create 100 hospitals and then see like which is performing the best. So we are going to create 100 virtual hospitals and then test all of them out. Which is performing the best, which has the I guess least solar radiation, heat gain and stuff like that. So that's so Grasshopper allows us to simulate things. And also it is a common platform for many simulations. Like you can do computational fluid dynamics, you can test out like create a wind tunnel, a virtual wind tunnel in let's say OpenFOAM or BlueCFD. But that software is only for this. It's only for this wind analysis. But Grasshopper allows many simulations to be hosted. And then there is customizability. So this is like next level. So you have learned the basics of Grasshopper. You know how the nodes work. You even know how plugins work. But even after that, if you want to do something that none of these nodes and plugins, okay, sorry, I'm speaking in technical terms. Okay, let's go back a bit. Grasshopper is not coding, right? It is simplified coding. In that simplification, it loses out many of the freedom a coder has. So there is a block that will allow you to create a point, but that's all it does. There's a block that will allow you to create a line, but that's all it does. You want to do something more, then you can do that. You can learn coding and then add a script to it. So basically, yeah, that's why it is an advanced level thing where you are done with Grasshopper basics. Now you want to create your own stuff, then you learn coding and I do that. So I have learned Python and C# because I did get stuck during my during my thesis, and even when I was writing the research papers, because then it becomes a niche. I'm looking at I'm trying to solve a specific problem, and for that specific problem, there is no plugin available, there is no nodes available. So I have to create something on my own. So yeah, that's why if you're taking this forward, don't worry, it is customizable. You will still move on. So yeah, let's take a short 2 minutes break, even for myself. It's pretty heavy on me. Any comments? Sunidhi, Mandir. Yeah, yeah, yeah. Yeah, 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 okay. Nice, nice. That's good. That's good. That's good to know. Because I was feeling bored, like listening to myself, just talking stuff. But that's good to know that you found it nice. Hi Ashwarya. We all introduced ourselves. Would you like to introduce yourself? I would just like to know, what are you doing? Are you a student or are you practicing architect? And how much of Grasshopper have you gone through? Hi Ashwarya. Mhm. Okay. Okay. Awesome, awesome, awesome. So yeah, there are, I think, three people who are very similar to you. I mean, you all have done your bachelor's, and then you're either pursuing masters or you're working. You have just started to work. So that's really nice. There is some similarity. Sorry, you in masters, have you thought about like what are you getting into? Is it in sustainable design, urban? Oh, nice. Hmm. Ah, okay, okay. Uh huh. Interesting. Wow, that's really good. I mean, you are investing in yourself. Yeah. Hope you. First of all, congratulations on getting that seat, and all the best. You'll do fine. No problem. No problem. Okay, let's move on. Um, its uses for sustainable design. Now we have looked at how Grasshopper is useful for architects. Now we are going to narrow down even more and see how it can be used for sustainable design specifically. So, there's a short definition that I wrote. Sustainable design is defined as design strategies and features that minimize the negative impact on the environment while promoting energy efficiency, resource conservation, and occupant comfort. So there are these three aspects that we are going to look at. It's pretty interesting to um, see that all these three things have a very different approach, um, different simulation tools that we can use to achieve that. So first is dynamic shading. Now, of course, the words dynamic is something that's moving, and there is shading. So we can maximize shadows by uh, creating dynamic facade. I'll show you one of the projects I did, college projects long back. Second, so yeah, this is done by responsive elements using sensors or clocks. So yeah, we can have sense. So if it is cloudy, the sensor will sense that there is not much light, and it will open up or close down, whatever you want to do with it. Thirdly, there is daylight simulations. It's so interesting that so some of you know what EPW file is. EPW file, basically energy plus weather files. These okay, so I'll be talking about this later as well. But in short, these carry the information of any city, information about the temperature of every day of the year, sun paths, exact sun paths through every day of the year, and yeah, relative humidity, wet bulb, dry bulb temperature. So basically, it is a file which has a lot of data in it. The data is not very easily readable. It's like a kind of a text file with a lot of data in it. What Grasshopper does is it can extract data from it and uh, create windrows diagrams, create heat maps, create sun path diagrams, and then you can even play with it. Like I only want to see 12 a.m. of summers when the sun is gonna be at 12 a.m. on summers, or 3 to 2 p.m. Sorry, 2 to 3 p.m. on summers, where the sun is gonna be, and then I'm gonna design shading for just that peak summer. So it's so crazy. Like you can easily visualize this boring data using Grasshopper. Then there is sun hours calculation, solar radiation calculation, CFD for wind simulation, and that is computational fluid dynamics. So it is all related to the properties of climate, the properties of the sun. What I haven't mentioned is, surprisingly, so all of this is useful for occupant comfort and even energy efficiency, but for resource conservation, um, we can create these parametric designs or whatever we are doing, and um, write a script that will tell you exact quantities of what you want. And let's say you are using laser cutting or some other computer aided, what do you say? I forgot the name. But yeah, so basically, sorry, what? 3D printing, yeah, no, so all of, just like all of these softwares are come under computer aided designing, all of these mechanical processes is called something, I forgot. Like all of these laser cutting, 3D printing, even those, what do you call that? I'm forgetting all these names. CNC, yes, CNC. So CNC is that term, right? Like all of these computer aided machines are called CNC machines, right? Am I right, Mande? Ha ha ha. There is a, just like we say open CAD, so it's understood that we are opening AutoCAD, but actually CAD is an umbrella term. Similarly for CNC, many people think that CNC is only that milling machine or those like carving machines, but actually anything, any machine or robotic arms or anything that is governed by the computer, that's CNC. That's so. Thank you, Mandir. Yeah, I was like completely brain blocked that I wouldn't have been able to sleep. So yeah. Thank you. So yeah, so we can use this scripting to find out what's the most optimum method of extracting these material with minimal wastages. So that is a resource conservation, uh, that is a part of sustainable design. So okay, let's move on to, are there any practical examples for these things? So in London, if I can visit this place. Okay, so in London, there is this building. So London is a place where everything is like preserved. The buildings, the architecture style, they are all preserved and they should look similar to each other. So even if you are proposing something which is, a bit off-putting, a bit off the beat, it has to go through a lot of regulations and stuff. So it's very difficult to, design crazy stuff in London and in the England. So that is one thing. So I'm surprised that even after keeping that in mind, these people were able to create something like this, which is a roof extension that was designed by Grasshopper. The design is looking very organic, but everything is calculated in terms of rain flow, that there shouldn't be any places where the rain is accumulating because it rains a lot here at random times. I think it is also responding to the sun shadow, sunlight as well. In winters they need sunlight because the days are very small and it's mostly cloudy all the time, and in summers they want to avoid because the people here have very less tolerance of heat. Like even if it is 25, they are burning and they're getting all these sunburns. So they want to avoid sunlight anyways. So there are these two things: rain flow, sun path, and thirdly, they have giant walls and folding windows inside it. Now, because this is an organic shape, it's not just a pavilion. Like you can create any random shape and that's it. There are functions inside. There are windows. There are doors. The problem with these are, like, normally these doors and windows are very universal and rectangular. So what do we do in this thing where the shape is organic? So it becomes a bit of challenge. Like you can see here, all of these doors, they are not a rectangle. They are trapeziums. All of them are trapeziums. The windows are trapeziums. The panels above are trapezium. That's like tessellated, some random shape. So these things are really difficult to um, make, in the sense, not only model but also get the accurate dimensions and extract these dimensions from it. Below is a bit daunting script that is governing the above design. So yeah, just get a feel of it. Like when you see a rendered image, you know how you can simply design it in SketchUp. Like, okay, he must have created a void and then created punctures and then extruded stuff and all of that. But Grasshopper, you have to forget everything that you know, and you are like making this I don't know, web kind of thing, and then a design is emerging. So this is like a completely different thing. So I'm just mentally preparing you what is to come. Now we'll look at Al Bahar Towers in Dubai. Oh, you must be knowing Mandir, right? Uh, oh, no way! Oh, amazing! Wow. Yeah, yeah. Second skin. Okay, okay. Ha ha ha. Yeah, yeah, yeah. 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 Yeah, yeah. Yes, yes, definitely. Wow. And like, is it visible, like, or is it very slow? I mean, I'm just curious. Ah, okay. Ha ha ha. Hmm. Makes sense. Yes, yes, yes. This is definitely, definitely. Yes, yes. So the parameter here is the sun path. So that's just really amazing. So yeah, you've explained it very well. So these panels, they are kind of flower like, and they open and close. Like you can see on this. Oh, I can zoom. Perfect. So like this part, the panels have opened up and they are creating this shade, and below they have closed down. So there is some indirect sunlight going in, because we need sunlight but we don't need direct sunlight. We need natural light but we don't need direct sunlight. So especially in Dubai, which is a desert. So yeah, this is a dynamic facade, dynamic facade. Now I've written here it's actuated facade panels. So technically speaking, uh, this how do I say? So there is any machine that is connected to a sensor and it is causing some mechanical operation by sensing something is called an actuator. I don't know if this definition is correct or not, but that's what I've experienced, and I'll show you. So actuation, actuated, and actuators, it means a sensor and some mechanical thing going on. So there are actuators connected to these panels which make them open or close, sensing the sunlight. Yeah, so this is simulating their operation in response to sun exposure and changing incidence angles during the different days of the year. Cool. So remember this. Uh, First, we talked about a form that is generated using Grasshopper. Second, we have designed dynamic facades that open or close according to the sun. Okay, so first is a static form. This is a dynamic mechanical thing. Now third, if you like see this building and not in my Grasshopper presentation, you would never say that this is designed using Grasshopper. So, but this has an element of Grasshopper. This third example is an example where Grasshopper was used to simulate daylight analysis, solar radiation, and energy calculations. Sorry, yeah. Okay, so this is in Seattle. And in 2013, it was said to be the greenest commercial building in the world, having achieved net zero energy. Of course, it's debatable, but yeah. So they use simulations to do the daylight analysis, solar radiation, and energy calculations. And then again, you can see these heat maps inside it. So there are, of course, many of you know a lot about sustainability. So you know that we don't want to create a battery effect. We don't want like direct sunlight hitting the slab and heating it up and then releasing it at night in places that are hot. You want that battery effect where it is cold to minimize energy consumption by heaters. So so we can simulate it, we can see what's happening, and then make design decisions. Because this simulation, this computer, this Grasshopper does not know what is best for us, what is best for the occupants of the building. It is just saying like, if you build it here with these many windows, with this material, this is what you're gonna get. Now you decide. Then we are like, oh no, there must be something better. Okay, so that's simulation. So computer is dumb, but it is extremely efficient and resilient. Like it can run through 100,000 options for us and things like that, repetitive tasks. But it is not going to design for us. So designing part is you. Now I'm going to contradict myself. I just said that it's not going to design for us. It's going to tell you what's happening, what's going to happen if you do this kind of thing. In the last session, we are going to see how to tell the computer to design for us. That is like that is done by creating a loop. Let's say the building is like controlled by 4 points, okay, and it's a square or a rectangle in between. Like you control these points and then you get the shape of the building, okay. And I've created the script, so I'm not just talking theoretically. Okay, and now I'm going to tell the computer, that you can do all these simulations. You can see what the heat gain and everything is going to be, right? I am telling you that it's a hot weather place, and I want to minimize solar heat gain, solar radiation, incident radiation. Now you tell me what these points, like move these points randomly and tell me what is the most optimum shape of the building. So what the computer is going to do is going to create a random shape and then going to test it, and it gets a solar heat radiation, let's say 300 watt per meter square or something like that. And then it does something else, it gets an average of 250. So it's going to remove the old one, and now it's going to do this for a long time, and like 1,000 iterations, like quickly, and it will give me the best 10 options, which has got like 200 watt per meter square. And then there are layers to it. Like I can introduce contextual buildings. Like there are building here, there is a tree here, there is another building here. Now tell me what's going to happen. I'm going to create constraints on it, that I need some setback. These are the bylaws. So now this has a next level of computational design where the computer and me are designing together, and it's pretty interesting. Like things go really crazy after that. So yeah, we are gonna look into that, and then machine learning and stuff also comes into play in selection of these options. It's pretty interesting. All right, so enough of talking. Let's begin Rhino, and we are going to look at the interface, how scripting works. I'll just demonstrate some basic script, and then you're gonna create your first script. You're going to look at a twisting tower, just create Voronoi, attractor logic, just to make you familiar with how designing works in Grasshopper. I guess, yeah. So that's the end of our presentation. So let's start up our Rhino, and till it's starting up, let's talk a little bit. Any comments as of yet? Shreya, Sharvari, Pratiksha, Polomi, Ashwarya. Is there anything that that comes to your mind when you look at all of this? Like, is there any case study that you did, or a project that you're doing and you think that probably can use it? Yeah, Mandir? Yeah, sure. Yeah. No, sorry. So this is not a render. This is an actual photo. And this web is gonna create the envelope. It can create these doors and shapes of the building. So yeah, it will create a render in Rhino. So you'll be seeing a rendered image, not a very nice render, but like a SketchUp render. Like you can just get a feel of what is happening. Of course, then you can export it and then do the rendering and make it like as how you want it to be. So yeah, so Rhino is open, and Grasshopper is pre-installed in Rhino. You just have to, where you like, in command you can write line and then create a line in this. Yeah, sure. Yeah. Yeah, so it is pre-installed. You don't have to install Grasshopper. Oh. Yeah, you can externally download it. Okay, so firstly, what's the version of the Rhino? Is it? Oh, perfect. Yeah, then it should work. Like you simply type Grasshopper in command and press enter, then the Grasshopper should work. But even then, if it does not work, okay. Yeah. So specifically, Ladybug is not working because Ladybug is like horrible. I mean, even if because if you update your Windows from 10 to 11, Ladybug stops working, Firefly stops working. If you update your Rhino from 7 to 8, Ladybug stops working. If you update your Grasshopper, Ladybug stops working. So it's a horrible software in terms of it's I don't know, it's not user friendly at all in terms of downloading it. I've spent weeks, like during my time when I was doing masters, Ladybug was still at its very preliminary stage. So I had to like open my command prompt and do some scripting and coding to install that bugger. It was so it took me 1 week to do that. It was crazy. And now like after 1 year, when I was so I take this sessions often, right? So last year when I took this, I was of the notion that, oh my god, I need to explain all of this to my students. But I just checked like what's the latest installation procedure, and it was so simple. Like you just double click this and it gets installed. I was like, and then I told all the students, like, you're super lucky. I would have to spend an entire session just to tell you how to install this. Is it Mac? Mac is even worse. Like, I had a Mac, a nice Mac, like things run smooth in it, and I had to ditch that because half of the plugins were not compatible for Mac, and this Ladybug, half of the module nodes of Ladybug also does not work on Mac, so it's just stupid. Yeah, yeah, yeah. No, definitely. Definitely, definitely, that's the case. I remember, like, no problem, no problem. I remember very clearly, like, everybody was using Windows. I had a Mac, and I was like banging my head. Why isn't this working? Everybody's script, exact same script is working, and in my thing it is showing a random error. Then I looked at the forums, and then I found out that all the Mac users have found the same problem. Yeah, so I'm glad you asked. So that's nice. I mean, that will help a lot of, like, reduce a lot of pain. So yeah, yeah, yeah. Yes, yes, definitely, definitely. Yeah, yeah, yeah. Otherwise, you'll keep on searching and you like just get frustrated. It's horrible. Oh, I can feel your pain. It's crazy. I know. No problem. No problem. So, so yes, so Grasshopper is pre-installed, and I think even if it is not installed for some reason, you can, just a second. Let me open up a new browser. So you can simply go to Grasshopper 3D and go to their website, and yes, you can download it. But you don't need to download it. Like, only if, yeah. So you see that Grasshopper is included after Rhino 6. So if it is 6, 7, 8, you don't have to worry about it. Before that, you'll have to download it. Look, see, latest Grasshopper for Rhino, Windows only, Windows only. Even in plugins, you'll find Windows only stuff. So it's sick to work on Mac. Even though, like, Mac is smooth, but still. So yeah, I type in Grasshopper and press enter. Now your Grasshopper will start very quickly. Mine will take some time because it has 45 plugins, so it's gonna take a while. But yeah, until then, how are you finding the session as of yet? Ashwarya, would you like to say something? Yeah, yeah, yeah. Okay. Okay. So you, I think, I don't know. I think you can install it again, but the student version is free. Oh, sorry, you're not a student. Okay, so yeah, 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 yeah. Let me see. I don't remember because the best thing about Rhino is, what I feel is, it's, firstly, it has got like one-time payment and it's only like 80K. Otherwise, like, AutoCAD and SketchUp and everything else, they are so expensive, and like they need subscription kind of thing. Um, but yeah, let me see. Uh, Rhino trial install. Even if you are not able to install it, it's fine. We can, um, you can, like, follow along my videos. Um, Sorry. Oh yeah, yeah. That's, of course, that will definitely work. Perfect, perfect. Yeah, you'll get a nice 90-day thing. Cool, 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 cool. So yeah, put that into download. My Grasshopper is still starting up. It's taken a while. Um, Follow me. How are you feeling? Cool, cool, cool. Thank you, thank you. Okay, so my grasshopper has started. Okay, so as soon as it starts up, my screen is visible. Just to confirm, what text is readable? Like, is it too small? Like, can you read all these files are available? Shreya, not visible, right? Okay. What if I screen share? Yeah, that should work out. In screen share, right? Oh, I can actually use my OBS to zoom in as well, I think. Kind of like this. Yeah, but let me try this. What do you call this? Screen share. Screen share. Uh, oh, perfect. So screen share is better, no? So I'll just change my video to just me, and just I'm using this thing for the first time, and it's nice, I think. Uh, cool. All right. Yeah. So when you open up your Grasshopper, you will see this getting started with Grasshopper. You can experiment like clicking on these things and play stuff. Actually, let's just try one of them. So as soon as you click one of them, you get this, a smaller version of what you saw, that web thing. Sorry, that small part of it. But okay, so let's just delete all of that. Okay, so when you close that window, this is what you'll get. A blank gray canvas. This is called the canvas. You can zoom out, zoom in, right click to pan. Like in Rhino also we do right click and then pan, like shift around. Middle click does this. We'll look at what is this later on. Clicking on the right click gives you a drop down menu. That will be useful. Left click, you can create this selection box, select the stuff. Okay, so now on the top, in my case you can see all of these letters, but in your case I think there will be 5 things. Params, that's parameters, I think. Maths, and this is what sets, vectors, curves, surface, mesh, intersect, transform, display, and after that all of these in my case are plugins, but before that, that would be common for us. Now let me open up Rhino as well. Yeah, so right now both of these things are opened up, Rhino and Grasshopper. Okay, even in Rhino, I you don't have to know anything about Rhino. Okay, it's fine. Just like in this case, just double click on perspective, so that window will open up. Okay, just do that, and yeah, that's it. Now whatever you're going to do in Grasshopper, it will be shown in Rhino. How do we move on? Let's let me sorry, let me just check my this thing. Okay, so let's go into how scripting works. Basic scripting demonstration. Okay, I think I'll have to do some sketching stuff. How scripting works. In AutoCAD, you want to draw a line. You click at a point. Of course, you do LI space or L space. You click at a point, right? Let's say the point is A. And then you click at point B. and as soon as you click it, automatically a line line is created. If you had said you wanted a line, draw a circle, circle. If this was the first, then this will be the center of the circle, and this is how like the entire circle will become, right? So let's break it down. Let's break down this basic action. First, what is the geometry that we are making? Okay, line or circle. Second, now the computer needs inputs. In line, it needs two inputs: the starting point and the end point. Okay. And what after that? Then you just leave it. Like the line is static. It's not going to change. Similarly for the circle, it needs a starting point to define the center of the circle, and then an end point that could be anywhere to determine the radius of the circle. Okay, so we are breaking down the process of designing, the process of creating any geometry. Grasshopper is the same. In Grasshopper, we want to create a line. Grasshopper will ask me where is the start point, where is the end point. But the thing is, in Grasshopper, I cannot simply show it. It's like a blind guy. I cannot like show it on Rhino that I want a point here and then the second point there. I have to talk in terms of coordinates. Like it will be on origin, and the second point I want it to be 5 units on the x-axis, positive x-axis, away from origin, things like that. Now the difference is I can change these coordinates like 5, 0, 0, 6, 0, 0, 6, 0, 1, things like that, and the line will morph. Okay, so I'm not physically touching the line. I'm literally just telling the computer, and that is coding. I'm telling the computer, change the line, and then the line dances itself. Okay. So first step, let us create a point. And then what I just said, we are going to do that. There are several ways you can start. So one is double click on canvas, and then this box comes up and you enter a search keyword. So I want to create a point. I just type in point. It gives me this, contains a collection of 3-dimensional points. Actually, we don't want that. Double click. I want to construct a point. Okay. Wait a second. Construct point. Yeah. Okay. So I misspelled it. So construct point, and we get this. What is this? So this is called a node, N-O-D-E, node. Instead of writing code, this is a code block. It has code in it. It is telling computer what to do, but we don't need to know what that is, because that's very technical, and that's not what we are getting into. So this is very user-friendly coding. Code blocks is also used to teach like 6th graders, 7th graders how to code. Okay. Now you can see that the Rhino has got this point. Yeah, and when I click here, that point gets highlighted. You cannot zoom into it because it's a point. It will always be that size. And you see when I'm clicking on it, it's highlighting, and clicking off it. So this means this node is creating a geometry in Rhino. Now let's dissect this node, because the entire Grasshopper is built on nodes. This is the bricks. This is the building block. Every node, or at least most nodes, will have inputs and outputs. Here it is asking for x coordinate, y coordinate, z coordinate, and the node is saying, I'm going to give you a point. You tell me these 3 things and I'm going to give you a point. By default, if I just keep hover my mouse over it, it is telling me one locally defined value 0. So it already has this value 0. This is also 0. This is also 0. And that is why I'm getting a point at the origin 0, 0, 0. Let's throw in some other number. Okay, so I told you, like, if you double click, you get this enter a search keyword, and then you can write whatever you want. You want to create a circle, you can write a circle, and then you'll see all the types of circle that you can create, even from your plugins and everything. Okay, so right now I want a number. So let's just double click. I'm gonna say number. So there is number, get number, clean number, numbers to points. Some of these you won't be able to see because these are from my plugins, but that's fine. Now remember this number slider. That's a very nice tool to create numbers. Okay, so number slider. This is like very commonly used. Double click, number slider, enter. That also gives me. So play with it. Like, you want to have a number slider, you can double click and then create a number slider. Or the long way is to actually search for it here. This is the number slider in the tabs. And then you drag it and then here. Or if you just click it, then it will, then also it will come. But I don't use that. It's crazy to navigate through all of this. And you can simply delete things. You click on something and press the delete key, it gets deleted. You click on something, you do Control C, Control V, you can copy it, or Command C, Command V if you have a Apple. If you press Alter key, and then drag, you get something like this. But if you have selected something and then you press an Alter key, you can copy it. Select all of this, start dragging, and then I'm pressing Alter key to get this. If you press the Alter key first, then you get this. This is just arranging stuff. I've barely used it, but like, if things are getting too compacted, I'm gonna just create space between them. But it's not useful because when it's like anyways, yeah, it's not useful. Okay, so let's delete stuff. So far so good. I'm taking it very slow. I hope everything's good. All right, where is the Rhino? Okay, now look at this point. Now we are going to connect the output of this node to the input of the other node. Okay, so we have created a number. Now how do I feed this number? It is by, you see these semicircles? You click here and then drag it and put it here. So that data is now flowing. Okay, so 0.25 is flowing into X coordinate. Okay, I'll wait for a while. Now we are going to see what that number slider does. The point is slightly moving. Okay, so I think now it is pretty self-explanatory, like what is happening. In a number slider, you can control the number output using the slider. It's a slider. This is going into the X coordinate of my point. So the X coordinate is, it's moving like this. But right now it is like 0 to 1 and it's like very less. You want to increase it, then you can do many things. If you double click, you get this. And don't worry about all of that. Just look into this numeric domain. Domain means start point, end point. So right now the minimum is 0 and the maximum is 1. So we want the maximum to be a lot more. Let's say 26. Okay. Now the point is moving a lot. 0 to 26. It's even going out of the screen. Okay. Let's remove these and copy. I do Control V, you can get multiple copies, just like any other software. Now we are moving it on the y-axis and z-coordinate. Z-coordinate is up, the height. Let me create a grid. Oops, sorry. I don't know why the grid isn't coming up. Anyway, so from the top view, you can see that it is going left, right, and up, down. And if I do the Z, it won't move because it is coming towards you. This is the top view. It is coming towards you. But if you go ahead to perspective, you'll be able to see everything. X, Y, and Z, up. When I create a line, it will be more clear. Okay, so you got it. Quick recap. This is a node. Every node has got input and output. We wanted to create a point. We did double click. I typed in, I want to construct a point. I got this node. And then this node is asking me, give me coordinates, X coordinate, Y coordinate, and Z coordinate. As soon as I created this new point, at origin, you can see that a point has emerged. I'm gonna copy this, I'm gonna move it, and then I'm gonna press Alt to get this. This. And now we've got 2 points. So you can create as many points as you want. You can simply do this also. And now you've got 4 points. Okay? If you remember the thing that I was saying, the building, so this is gonna be like, I guess, preliminary to the end. The building that we are controlling at 4 points. So we are gonna tell the computer, control these 4 points, these 4 sliders, create random values and check what's the output coming in. So the computer does not know that a building is being checked. It just looks at, okay, I'm putting these numbers and this number is coming out. I want to minimize this number. So I'm going to keep playing with these numbers till I get the least number. So, yeah, you get a hint of what's going to happen later on. And we don't even have to look at the Z coordinate. It's just the X and Y. The base of the building will always be on the ground floor. So, yeah, so reach here, create these points, play with them. Who is done with this? Okay. So I'll pause for a while. Creating a point is like the hello world for a computer engineer. Like the first script for a computer science or computer engineer is always print double inverted commas hello world and then semicolon, and that gives out hello world as their first introduction to computer. So for us, it is the point, the most basic element of design. And then everything is extracted from it. Point, line, plane, solid. So yeah, so going through this process actually gives you a different type of creativity in your general designing as well. The way you think more objectively, and it's just interesting to work with it. So for example, how much time do we have? 40 minutes, I think. Yeah, so for example, there is this protein box franchisee that is just coming up, and I am their architect. Um, and what I really want to experiment is, so since it's a franchisee, and we for franchisee we create a set of design elements that will be common for the cafe, that gives the cafe the identity that it belongs to protein box or McDonald's or Starbucks, right? It gives an identity, the branding. So what I am trying to do is create an elaborate Grasshopper script that is gonna create the cafe. You give me the context, you give me the site's boundary and stuff like that. I just have to put that in, and the cafe should pop up along with the facade, furniture placements, and windows, fenestration. So yeah, it's at a very basic baby stage, but that's gonna be crazy. Like if I'm able to do that, I think I'm gonna come on the newspaper or something, hopefully. But yeah, that's gonna take a long while, for a year or maybe year and a half, and that requires complete passion, because you're not gonna get paid for that. It's something that, in Hindi we say it, "Meri khujli hai wo." So, uh, so yeah, that's so. So you see, like since I learned scripting, then I was able to think in that terms, to define certain rules for that cafe, algorithmic rules, and then the cafe will pop up. So yeah. Thank you. But yeah, don't. I mean, I don't know. Don't have like too high hopes. I might just fail and like create nothing, but I hope to create it anyways. True. And you enjoy the process. That's awesome. So yeah, so we've created points. Now we are going to create line. Um, there is another way to input nodes. Like right now I did double click and then I type anything, I get stuff. Other method is to press space. Oh great, so it gives me the same thing. Okay, so I got confused with Dynamo. Dynamo is also a virtual scripting platform. It also has Ladybug and stuff. You can create oh yeah, so this is actually important. If you learn scripting in Grasshopper or Dynamo, anywhere, you have learned how to script. It's not Grasshopper that you have learned. You are not bound to that. You have learned how to script. So let's say you know how to draw with a pencil. You can draw with anything now, like basic drawing at least, with a pen, with a sketch pen, with a this is right. So Dynamo, Grasshopper, these are sketch pen and pen, and you know how to draw. Like I'm teaching you how to draw. Okay, so if there is a model in Revit and you want to run simulations on it, you don't have to like export it, put it into Rhino, and then run the simulations in Grasshopper. You simply have to run Dynamo in Revit, install Ladybug, which is even worse there, but still it can run basic stuff, and you can do that. So I'm giving the example of Ladybug because it is most useful, but there are many other things as well you can do on Dynamo. So I take Dynamo sessions also because I know how to do Grasshopper. It's very easy. But it gets very confusing, because the interface is a bit different, just like Rhino is different than SketchUp. But yeah, so you, don't worry, you are not learning just Grasshopper. You are learning virtual scripting. Virtual scripting, that's the discipline you are learning. Okay, so I digress. I was saying space, and then I do line. Okay, now there are many lines that we can have. There is line SDL. SDL means starting point, give me a direction, and then give me the length. Okay, so it's like a polar coordinate system where you're giving the first point and then you are just telling which direction you have to go. Another line is give me start point, give me end point, I'll create a line. That's another type of line. I guess that's it. Yeah, so there are two types of lines. So you can see that there are two lines written, but they are different. Okay, I'll show you both of them. Okay, space line, then the other one. Okay, so one was black and one was without black. The black one was, yeah, I don't know. Yeah, follow me. Yeah. Yeah, that's fine. That's fine. Okay, so there is a different display setting. Um, Preview point flavor. So your flavor is set to cross. Now even my flavor is a cross, and I think yours would be red cross. Mine is a gray cross. So you can change all of those settings. So don't worry about it. No problem. Look, now the point is red dot just like yours. So why I do not keep it red? I completely forgot why. Um, yeah, I think yeah, right. So when we have like a massive geometry, and it has got like lots of a mesh of points on it that has got panels. So all these point becomes like red crosses, and it looks horrible. So I just put it gray, and I just put it in spheres. So yeah, I'll just show you what it is. On the top tabs, go to display, go to preview point flavor, and you can put in whatever you like, and display preview settings. And there are two types of things. So one is normal, when you don't select anything, what's the color you want, like right now, let's say it is red. And when you select it, in my case it turns yellow, in your case it turns green, because that's the default. So let me just put in green in my case also for now. Okay. So now when I select it, it is green. So yeah, this is like really good to figure out which node is corresponding to which point. Okay, cool. Now line. So yeah, we've got two types of lines. This was the black thing line, and this was just normal line. This line, um, this line can hold a actual physical geometry from Rhino. I create a line in Rhino like by hand, and then this line can hold it if I tell it to. Let me show you. I create a line on Rhino, and then I come to Grasshopper, right click, select one line or set multiple lines. So if there are like many lines, all of them can get into this node. So this time I just have like set one line. Oh, so I'm setting one line. So I'm actually creating a line. That's even great. The other one is set multiple lines. Wait a second. Oh, how do I? Sorry, just. No, sorry. No, so it is giving me this. Look. Select. Yeah. No, so that works definitely for this one. Like I never use this line. I use geometry. So this one has like set one geometry, then you select it, and that geometry is now set. If I have like multiple lines, then I'm gonna do set multiple geometries and then drag it just like you said, and then press enter. Yeah. But I'm surprised. Ha. Okay. Understood. Let me check. Oops. Yeah, I was exactly the same thing. That was surprising. Let me just check. Points, set multiple points. Oh no, I can set points. Interesting. So the thing is, well, I never use these line and point because geometry can have everything: meshes, surfaces, line, plane, point, yeah, everything. So even for line, I use geometry. Even for point, I use geometry, and I can rename it. So for any node, oh, am I going like too fast? Let me think. Um, okay, so I have been explaining that these type of nodes can hold geometries from Rhino, physical geometries that you create in Rhino. It can hold them, okay? And all of them have the same thing: right click, set multiple points, set one line, or right click, set multiple geometry, set one geometry. Okay, so you create things here, you go here, you create this node, right click, set geometry, go back to Rhino, select those geometry, and then it goes in. And then it becomes gray. Like previously it was orange like this, now it has become gray because it has some value. You can right click and even rename things. I wanna rename points ABC. So now that geometry thing has been renamed. The crazy part is that you can even rename these things. I can write like hello points. Like this will be the first points that we created. So yeah, you can rename that. Or you can even rename these. X, Y, Z. Then you can group stuff. Let's say all of these are points. You select all of that, Control G, and they are now in a group. You can move the group like together. You can change the color of the group. You can name the group all points, and then this all points comes up. Yeah, you can change the color of the group. You can change the type. You can just like play with all of these things. I mean, this is not very important for now. Yeah, you can play with this forever. Okay, so yeah, you can group stuff. You can rename nodes. Let's go back to line. So we know how to take points, take geometry, and put into Grasshopper. We know how to create points. Now we are going to create line. Line start point, end point. So it requires a start point and requires an end point. We already have points. So do this by yourself. Just connect these to this and see what happens. And you know what, like after that, change the slider and see how your line dances. Let me delete all of this. Oh. Yeah. Did anybody get a dancing line? Nice one there. So yeah, you do this and you get a line. And by dancing, I mean when we do this, the line is changing. So like and first, the first feeling I got when I did this was the line is not at all in my control. Like it is so difficult to control the line. In AutoCAD, I simply have to select this and then like, let's say I want this line to end here. I'm just gonna like drag it and put it here, right? But here, when I have to do that, I need to figure out what's the coordinate of that point. Then I have to figure out what node corresponds to this point, and then set the numbers here to like get it close to that point. So yeah, I mean that's the first impression you get. That's completely fine. Don't be disheartened with that. Because you're going to see later on like why this. So this process has a different kind of designing that you have to do. You cannot think the old way of creating planes and lines and punctures. There's a different way of thinking when you're designing through scripting, and you'll get that very quickly. And that would be like, I think we'll do that like rapidly right now because we've got 25 minutes. Don't worry if you don't understand everything, but just like observe. Looking at, yeah, let's create that twisting tower. So yeah, we've created line. Let me throw in another line here for the sake of fun. Oops, sorry. Oh, and when you want to disconnect a line, select, press Control, and then this. If it is a Mac, don't press Command. Like find out that CTR button, and then do that. Shall I? Okay, let's just leave it till here. I want to create a twisting tower. A twisting tower, it will have a base of any shape. For the sake of simplicity, we'll take it as a rectangle. Then later on, I'll tell you like what can we do with that. Okay, so we've got a rectangle, and we want it to twist, right? So it's not simply that I've got a rectangle here and then I've got a twisted rectangle there and I'm gonna loft it. Actually, that is a method that we can do, and then we can like slice it down, create contours. But what I'm gonna do is, I've got a rectangle here, and then the next rectangle will be one floor up, 3 meters up, and then some degrees rotated, at the center, 1 degree, 2 degree. Then another with 2 degree rotation, another 2 degree rotation, okay? This exercise will demonstrate the definition of parametric design, physical parametric design. The parameters will be floor height, length and breadth of this rectangle, the rotation of each floor, 2 degree, or is it 1 degree or 1.5? Okay, so yeah, let's figure that out ASAP. Okay, so let's say you are working and then you don't want the script, but you don't want to delete the script. You select all of that, press the middle mouse button, and then you can disable preview. You see that blindfolded guy is gonna disable the preview. Also, you can do this, disable. Disable turns off the script. Disable preview hides the script. So if there's a heavy script that is working and then you are creating a new script, disable that script. Don't disable preview it, just disable it, so that when you're working, I mean, that is also computing, this is also computing, too much workload, the computer is gonna go off. So disable it. But once you disable it, then there is no output coming out of this line. Okay, let's go. Let's create a rectangle. Double click rectangle. There are a ton of rectangles we can create. Let's create this one. I think so the radius is the corner fillet that the rectangle can have. The X and Y size is defined, and plane is basically what orientation it needs. Right now it is in the XY plane, which is the ground plane, which is good, and it is at the origin. We'll talk about this later because, yeah, we'll talk about this later. But okay, so we just wanted a rectangle. I got a rectangle with X and Y size. Actually, the rectangle is this. The grid, yeah, Shreya. We can model in Rhino. So I can start off with a rectangle on Rhino also, simply. I can create a rectangle. I can go here, do geometry, right click geometry, set one geometry, select this. Now this is my rectangle. Okay. Just the thing is, yeah. So we won't be able to control this rectangle from Grasshopper. You see, like, let's say I want the breadth of the rectangle to be 5 units. In this case, I simply have to do this, like 6 meters, 7 meters, 8 meters, 9, 10 meters. Okay, I can control it here. For this case, I will have to change the rectangle in Rhino. I can even make it like trapezium or something like that. We can do both. There is flexibility for both, but I am like, for the sake of teaching Grasshopper, I'm purely doing it in Grasshopper. But I'll show you, because like after I create the script, I'm going to replace this rectangle with some random shape that I create in Rhino, and the script will work the same. So that's where we are gonna get. Yeah, no problem. So yeah, I'm gonna remove this geometry. Alright, so we got a rectangle. It needs these inputs. Also, you saw me just like write a number and then press enter. So yeah, that's even a shorter way to create a number slider. Yeah, I can go deeper into it, like how I can create specific number slider from, let's say, -10 to 40. So now the number slider is -10 to 40, and then you can have, yeah, you can do several things. But okay, so 0 to 10, we've got a number slider, we've got a rectangle. Now we are going to move on to the concept of copying and moving. In Grasshopper, there is not a single command that copies anything, that copies a geometry. That is because it does not need to copy. A grasshopper is crazy, like when you think about it. It is okay, let me explain to you. Let's say in CAD, you create a line and then you move the line, okay? When you move the line, the original line is being moved, correct? In Grasshopper, you create a line and then you move the line, the original line remains and the new line also remains. So it is kind of fourth dimension where you can see the past and the present of the object. You see the past of the line was the original line and the present is the moved line, and you can see both of them in Grasshopper, and you'll understand why this happens. I'll just show you. So I want to move this rectangle up 3 units. Okay, let's say we are talking in meters, so the rectangle is 7 by 10 meters. I want the height of the building to be 3 meters. So double click, move, you get move. Translate an object along a vector. Okay, I'll take a short 1 minute break because that will help to learn better. Any doubts? Yeah. Mm-hmm. Yeah. Thank you for like telling me. I completely forgot to tell you about it. So to do that, yeah, draw full names. So go to display and then select the third one. Now mine is like yours at GTGX. And then draw full name. Does that work, Mandir? Awesome. Like there are so many things to tell, and then I just get lost what to tell, what not to tell. If you ask me about number sliders, I can go on for like 20 minutes, 30 minutes. So I have to stop myself and then think what's the best way to give you all a holistic understanding of Grasshopper. So cool, yeah. So display, third is draw full names. Then there is this draw icons. So if you are looking at this and you don't want this, you can simply click on this and then get rectangle move. Sorry, Sharwari, you were saying something? Ha. I purposefully did not touch that because it will take a bit of time to explain it, the plane part. Yeah, let's just forget about it. Just imagine that we need a rectangle with x and y size. Okay. Yeah. Thank you. I think even in circle you need a plane. Let's see. Yeah, circle also requires a plane. So yeah, plane is something we'll look at later, or I mean it's fine. You can look at it like it's not necessary to understand virtual scripting. All right, let's move on. So we need to move. The move command is asking me for geometry and it is asking me for motion. Whenever you don't understand completely what it is asking for, you can simply hover your mouse over it and it will give you the details. The geometry, it is saying base geometry, and it has empty geometry parameter, which means it does not have any input because I haven't connected anything. Motion, translation vector. Okay, so I'll explain what translation vector is. In mathematics and physics, you must be remembering we've got scalar quantities, vector quantities. Vector is anything with a magnitude, with some number and a direction. I cannot tell you like move the box 5 meters. You like 5 meters where? Like up, down, left, right, towards me, away from me. You need to define a direction to tell me, right? So that's a vector. Move the box 5 meters to the east. That's a vector. So this is what it is asking me for. It wants me to tell it exactly which direction and how much does it want me to move. Directions, so there are several ways to do that. Right now, in this case, we want the direction to be up. In the Cartesian coordinate system, that is like x, y, z and everything, the z coordinate is the up direction. We can check that. How do we check that? There is this gumball that comes up. Let me see. This gumball. Oh, am I upside down? Okay. Now it's correct. So I think green is x. Oh yeah, you can see these coordinates also changing with your mouse. So, okay, so green is y because my y is increasing, x is stagnant at -10, y is increasing, y is decreasing. X is increasing, x is decreasing. And then z would be like this, but it won't capture because I'm in perspective. The front would be like that. So now, oh. Anyways, you get the point. So the blue thing is z axis. So I cannot simply give it a number. I cannot type in like 5 and put in, like do this actually, and it will show you an error. It's saying like, okay, are you stupid? Like what? Where do you want me to move? 5 meters where? So data conversion failed from number to vector. It does not want a number, it needs a vector. Okay, let's just simplify things and directly move towards z, unit z, okay? So when you want to move towards z, you type in this, simply type in z, you get unit z. If you want to move it in x-axis, double click x, you get unit x. And then you put in the number here, 3, 5, so much. Let's say we want to move it 3 units. Okay, so 3 units in z direction, I want to move it. Okay, that's the way I'm talking to the computer using these things. Now what's the geometry? The rectangle is the geometry. Now the new rectangle that has been moved up has popped now. And now the thing I was telling, that the past and the present of the rectangle is simultaneously being seen. That is because this node is not deleted. So this node is representing that rectangle. This node is representing the moved rectangle. So that's why both of them are visible. If you want to hide them, you can hide it. Then it is as if you have copied it. And then you can move it up, down, whatever you want to do. If I change the original rectangle, my final rectangle is changing, right? Because the data flow is like this. If I disable the original rectangle, my final rectangle also disappears because there is no input. Oh, sorry. Why isn't it? Okay, so but if I disable preview, then it's fine. It's just hidden. Okay, so we've got the base rectangle. We've got the first floor. Now I'm gonna go like super fast. I've been going through too slowly. Okay, so now I moved it. Now if I want to move it again, I've got this method where I can simply press shift, select all of this, and then copy it. Select the moved geometry into the new geometry, and then another moving is occurring. Okay, so there's the first rectangle, second rectangle, third rectangle. I can change the heights separately for each of them. I want to create a tower with 50 floors. I'm not going to do this 50 times. And when I want to change the floor height from 3 to 3.2, I'm not going to change all of these sliders. Well, there is a method actually. You can simply select one slider and give that as the input for both of them and do this. But yeah, I mean, you have to do this 50 times. That's not feasible. So then comes series. Series is a mathematical tool. It creates a set of numbers. It does not create any geometry. It creates a set of numbers. So if I want to create multiple floors, this is another way I can do it. I can simply have more number sliders which are increasing, like 2, 4, 6. Oh, sorry. Oh, sorry. You have to press shift while putting this in for all of them to combine. If I don't press shift, then it will disconnect everything else. Then you have to control Z. So as you can see, I am creating a 2, 4, 6, 8, 10, 2 meter height floors here. Series can do that very easily. The starting point will be 0. The step, which means, is it 2, is it 3? That is the floor height for us. And count, what are the number of floors we want? I said I wanted 50. I'm going to simply put this in here and I get all of these 50 floors. Okay. Okay, that's too much. Let's reduce the number of floors. I can change the heights. I can do anything I want. I can, so I've used this part. If you have a stilt of 4 meters, then you can do that. Later on, if you have refuge floors with a different floor height, you can create a mathematical script to do that. It's very simple. It sounds like mathematical, algorithmic stuff, but it's easy. It's easy. It's not tough. All right, so yeah, we've created a building with some number of floors that is controllable. Does not matter how many floors. Whatever you tell me, I can create that building. Like, now I'm going to twist it. So we want to rotate. Okay, let's go back a little bit and figure out how rotate works. We know how moves works. Okay, let me just disconnect it for you. Now, if this is a rectangle, ignore the that grid part. Just ignore it. Actually, we can do this. Oh, that does not work. Okay, anyways. So yeah, we've got the rectangle, this green rectangle. We are going to rotate it. What is that rotate node asking us? It is asking for the geometry. Let's connect the geometry. It has already rotated it around the origin. Now here it is asking for an angle. The rotation angle is in radians. We'll convert it into degrees. And thirdly, plane. So actually now we need the plane. Since the time is less, just bear with me with minimal explanation. Just blindly follow my recording, I guess. So there is this area command. Okay. If you put rectangle into this geometry, you of course get an area, but you also get the centroid of it. We want to rotate around the centroid of the rectangle. You can see even in the Rhino, the green dot has appeared. So this centroid will go into plane. And you see now the rotated rectangle has rotated 90 degree around that plane, around that center. Don't worry about these terms like, oh, this is plane, but I've put in a centroid point. How does that make sense? Just ignore. That's a very valid question, and it requires a bit of understanding of several things to figure that out. But there is no error here. Like, yeah, just trust the process. Now we'll figure out angle. Right click, degrees. Now the angle is in degrees. I'm gonna put in a number slider. Okay, let's do like 30 degrees. And now the rectangle is rotating. All right. Yeah. Okay, so now we have figured out how to rotate, how to control the axis of rotation and the degrees of rotation. If you remember the move thing we did, we created a series of numbers, a table, you could say, 0, 3, 6, 9, 12, right? And each of this number is associated to each of these rectangles. Okay, so this rectangle, let's say in the middle, is associated with 15 height from the bottom, and then 18, then 21. Now I want degrees associated to each of these, and the degrees will be in an increasing fashion. The first rectangle is 0, the second rectangle is 2 degree, and 3 degree, 4 degree, 5 degree, or anything. Now we need to combine these two things, right? So I've moved these rectangles. I am going to rotate these rectangles. Now the problem is this, let's say I'm doing 34 degrees. All of these rectangles are being rotated by 34 degrees. There is no series, right? So we need to create a series. Let me just hide this and show you what's happening. Okay, like all of these rectangles are associated with that same degree. Now let's create a series of degrees. Degrees will be, like we want 2 degrees difference, right? So the steps will be 2. The count, the number of degrees should be exactly the same as the number of rectangles. It's obvious. If I have like 2, 4, 6, that's it. That's the input. But the rectangles are like 50. Then it's gonna rotate 2, 4, 6, and then it's probably gonna show an error or probably gonna just repeat 6 throughout. That can be actually a design element. But for our case, we want the number to be exact. So what we're gonna do is, we're gonna find out where is that number of rectangles coming in. This is defining the number of floors. This is defining the number of rectangles. I'm gonna take this. I'm pressing the left key and then scrolling out and in to reach here. Okay, so so whenever I change this, I don't have to worry about how many degrees I'm getting, right? It will always be the same. All right, let's try to put it in. Oh, it already worked. Great. I thought I would have to graft and then I'll have to go into, so that's perfect. So it is working directly. Let's play with this. So the twist can be controlled as you want. Okay, so that's the next attribute, layer of attribute that we have added. Let me just hide everything else. Yeah. Okay, so that's the degrees thing. Now we can add another layer. Yeah, sure. Uh, yeah. Oh, the area thing. Yeah. Yeah. In angle. Yes. Yeah. So I did the degrees. Yeah. And then if it is radians, then it becomes perfect. Now the thing is, like we can do anything with this. Add another layer where the building is tapering, or probably the building is becoming like a sinusoidal. I forgot the name. Sine curve, basically. The sine wave. It can have the, that shape. It can look at damped sine wave. It can be cone. It can be reverse tapered. We can do all of that by changing, like adding layers to it. So yeah, I think this should be it. We can add a like skin to it. Just did a loft. We can give thickness to it. We can create surfaces for the slabs. Okay, I forgot. How do we do that? Yeah, we can do that, and then we can extrude it to get a slab thickness. Then we can take out the volume and calculate the exact amount of concrete you need, and what's the cost of that concrete. I can instantly tell you how much the slab is gonna cost within 5-10 minutes. So, and then you can add columns to it, maybe however you want to. You can explode this, get points, and then create ribs for a facade, and then I can tell you what's the entire length of steel that is being needed. And if you tell me the cross section that is required, I can tell you that weight, loads, again costing, everything. So that's how we expand over it. And once this is set, once it's not like I'm taking out the costing for one specific design or thing. I just have to create a chunk of script that is going to calculate the cost of the glass that is needed. And then I can change this building. I can increase the number of floors, I can increase or decrease heights, can change the size and everything, and then it will still work. That chunk of script that I created to calculate the glass cost, it's still gonna work. So that's the power of Grasshopper, I guess. Yeah, so I think I should stop here now. It's pretty late there. It's 6:30 p.m. here, but it must be 11 p.m. there. And yeah, any questions? Or maybe I'll give you this script, and you play with it, open it up, and then you'll of course you let it sink in, and then you will run through some errors, doubts. So you can definitely ask it in the group, or in the next session, definitely. So yeah, that would be all, I think. Thank you for being so patient, and hope you enjoyed the session. Okay, then, good night. Thank you, Rasit. Yeah, bye, good night. So that was the end of my class. So this was amazing. I mean, I love teaching, and that was so satisfying. Oh, the OBS is also recording. Nice. Oof. Yeah, pretty cool. The OBS did not record my screen because oh right, I hit the screen and then I exploded my video. The students were amazing. Like, they were with me. Nobody left. Pretty cool. So tired. All right then. See you in the next one. So day after tomorrow, I've got the next class. Um, Also for Udemy, I'm gonna Udemy and Skillshare and all of that. I'm gonna record a few modules, but I'm gonna do it tomorrow. Today I'm tired. Whew, crazy. Anyways, see you in the next one. Bye.